So my name is Emma Hauser. I'm an aquaculture outreach specialist for Wisconsin Sea Grant and also the University of Wisconsin-Stevens Point Northern Aquaculture Demonstration Facility, which is what you see behind me here. We are inside of our aqua barn. So the aquaculture facility is a northern campus of Stevens Point that specializes in research and demonstration and education for sustainable aquaculture. So aquaculture means the culture or rearing of aquatic organisms. Here we just specialize in fish. So we have various species of fish here that we're doing research on. Wisconsin Sea Grant funds a lot of our projects, especially our projects dealing with walleye. The facility has been in operation since 2002, and we are actually on tribal reservation here. So we are on the Red Cliff Tribe of Lake Superior Chippewa Reservation, and so we have a direct partnership with that tribe here to be stationed in this location. So we have a number of different fish species. We specialize in fish that are basically for a northern climate. So we don't really have a lot of tilapia or catfish or warm water species here. We have species that do well in a northern climate and have markets in a northern climate. So that's species like walleye, Atlantic salmon. We have conservation projects on species like lake trout and lake herring. And we've done over 15 different species of fish here. At one time, we've had as many as 8 different species here. And some of the other species we've had in the past include yellow perch, lake sturgeon, various bait fish species. And it really just depends on the year, who's funding the project and what the current research questions are. Walleye is a very target species of ours and has been for the last 25 years. We are one of the few facilities in the country that is raising walleye intensively, meaning raising walleye indoors from hatch. We start them from hatch inside. We can raise them all the way up to a market-sized fish in a little over a year, and that's really important for our food fish market. And also raising fish indoors enables us to do research because we have a completely controlled environment. So some of our research is looking at different temperatures of raising walleye, for instance, or different densities, and we can do that all in an indoor environment and control that instead of relying on something like outdoors in our ponds where we can't necessarily control things for research. Another really important part of our walleye research is looking at brood stock. So we are one of the few facilities in the country that have an indoor raised walleye brood stock that we can actually manipulate to spawn out of season. So we can manipulate these fish to spawn using temperature and photoperiod cues to get them to spawn out of season. And this is a really important project that has been funded by Wisconsin Sea Grant over the years to really figure out what is the proper temperature to cue these fish to spawn. Now that's great for the food fish industry because if we can spawn fish year-round, now we can have eggs year-round and support the growth of the food fish industry. But it's also a really important question for conservation. So we can really understand what are the optimal temperatures that walleye need to be exposed to spawn. And in warming lakes, maybe those fish aren't getting the proper cues to spawn successfully. So it's kind of a conservation question and research as well. Each one of these systems is its own kind of mini recirculating system. So we are able to use recirculating aquaculture technology to be able to manipulate different temperatures of these systems. So as I mentioned, some tanks are staying in a warm water environment, 70 degrees, and some tanks are being chilled down to more of a 46-degree environment to cold bank these fish. So recirculating aquaculture gives us the ability to control temperatures in this environment so we can do the research properly. So these fish are going through this cold banking process. So what we're doing is we are cold banking different groups of walleye at different stages of their lives. And the idea is that it's slowing their growth down so that we can have production year-round. So these fish are going to be cold banked for 60 days, so 2 months. We're going to bring them back into warm water, and we want to see how their growth changes. So do they go right back onto whatever growth schedule they were before they were cold banked? Do they have something called compensatory growth, where they grow faster to catch up to where they would have been? And so these are all questions that we want to answer for the private industry, so that instead of getting eggs year-round, they could rely on something like cold banking and hold small fish until they're ready to bring them up into warmer waters and continue their growth to production. So we have what we call our warm water side and our cold water side. So in our warm water side, we have a warm water recirculating system, and we are raising fish like yellow perch, walleye. We've raised sturgeon on this side kind of as our warm water species. A lot of these A lot of our research in all these tanks have now walleye in them right now. So I can show you these fish. These were last year's walleye. And we are holding these fish to support our brood stock. So these fish have been raised indoors their whole lives on a commercialized pelleted feed. So these are our walleye brood stock. We have 4 tanks of walleye brood stock right now. These fish are anywhere from 6 to 8 years old. And we recently finished a project looking at the optimal temperatures in order to cue these fish on when to spawn. So we understand that walleye need a cold period or a winter temperature in order to set their eggs to spawn, but we don't really know how cold does that need to be and for how long. So Wisconsin Sea Grant has funded multiple years of research to really understand kind of how cold do walleye need to be and for how long in order to spawn successfully. Fish feed for aquaculture is a really important part of raising fish, of course. So a lot of research is going into creating different diets for different fish species to raise them sustainably. Feed is probably about 50% of your cost as a fish farmer. So you want to make sure that you're buying the proper feed for your fish, but also to make sure that economically it's going to work for your system and your fish that you're raising. So we have all these different bins that have different types of feed for our different fish species. For instance, we have very large pellets for our larger species. Of course, this is for our Atlantic salmon. So our Atlantic salmon are reaching over 30 pounds, so they get a much larger pellet, while some of our smallest fish get a very small diet. So this is what we would call a 2 millimeter size diet, extruded pellet. So it's really important to understand not only the feed has to be specific for the fish that you're raising, but also that the system that you're raising your fish in. So we buy specialty feeds for our recirculating systems that aren't going to break down in the water and degrade our water quality. So we really we're paying extra for diets that do very well in water recirculating systems versus, say, a pond system where it doesn't matter maybe too much about breakdown of that feed. So fish can either be hand-fed to satiation, which is basically feeding fish until they look like they've had enough to eat. But it's also really important to understand how much feed they really should be getting on a daily basis. So we actually measure our feed out on a daily basis depending on the total body weight in the tank. So we are sampling our fish every couple weeks to understand their growth rate, understand how much they weigh. We apply that to the entire tank, which is called total body weight. And then we're feeding a percentage of their total body weight per day. So it depends on how old the species is. If it is kind of a mature or adult fish, we're feeding it like a 1% total body weight per day. But our young fish, as it would make sense, they're younger, they're growing faster, their metabolism is faster. We're feeding them about a 20% total body weight per day. So we will measure that out on a daily basis. Even though we do use feeders, automatic feeders, it is really good to hand feed our fish regularly to make sure they're responding well to feed. The minute fish are not responding to feed, that means something's wrong. That means they don't feel good or they are sick, something's happening with the system. So that's sort of our first cue to realize if we have sick fish, right, if they're not feeding. And that gives us kind of an insight into mainly water quality issues usually. So we would do a water quality test to make sure everything is okay. We would try to figure out the issue as quick as possible. So fish are very sensitive animals, and the first cue that we can get to realize something is wrong is really critical. A lot of aquaculture is turning to water recirculating systems, or RAS, and that's really important because water is a very valuable resource, and being able to reuse your water is amazing, but plus you can concentrate your solid waste. And a lot of farmers are using that solid waste as extra income, as fertilizer. So it's a system that makes a lot of sense, especially in our cooler climate. We can raise fish year-round in an indoor recirculating system at whatever temperature that we like. So this is an example of a warm water recirculating system where we are raising different stages of walleye. So the very first step in reusing your water is removing the solids. So this is called a drum filter, and this is mechanically removing solid waste from the water. So that means fecal material, leftover feed. When the drum becomes clogged or filled with solids, it will trigger itself to spray and turn, and it sprays itself clean. So it will spin and then it will spray all the solids into a trough. All of those solids go into a trough that goes out into our settling basin where those solids become concentrated and where we can dredge those solids out and land apply that as fertilizer. So getting those out is the first step. The second step is called biofiltration. We are pumping the water from the sump through something called a biofilter. So a biofilter is raising good bacteria that is cleaning your water for you, just like it would in an aquarium or just like it would in the natural environment. So there are two different types of bacteria that are growing on this layer of sand here. So all this is sand. It provides a lot of surface area for good bacteria to grow. So what's happening in here is called the nitrification cycle. So that bacteria is eating up things like ammonia and nitrite and converting it into nitrate, which is much less toxic and much safer for the fish. Again, this happens in the natural environment, this happens in the water, in the air, in the soil. We're just controlling it here and we're offering a lot of surface area for that good bacteria to grow. So our water is being cleaned in the biofilter. It comes up and over into something called a degassing column. So we are taking CO2 or carbon dioxide out of the water because the fish are producing CO2 just like we are. So we are degassing that from the water and then it gravity feeds back into the sump. So before the water goes back to the fish, we want to sterilize it using ultraviolet irradiation or UV. So inside of this tubular structure here are UV bulbs that the water is passing through and killing any kind of pathogen or disease that we wouldn't want the fish to be exposed to. We also have something called an oxygen cone that's injecting pure oxygen into the water. So when you're raising fish at a very high density or higher density than kind of your classic aquarium fish, you want to be able to provide pure oxygen to those fish. So we inject pure oxygen into the water before it goes back to the fish. We'll move on to our cold water side of the facility, and this is where we raise a lot of our salmonids. So that could be trout or salmon species. Right now we have Atlantic salmon being raised in 5 different tanks here. So these Atlantic salmon are a specific strain called the St. John strain. They're reaching 4 years old, or they will be 4 years old this fall. And there's both males and females in the tank. And these fish are going to be part of a broodstock project of ours in the future. So we are working with both Maryland and Maine to look at a lot of Atlantic salmon broodstock research. So this is a current project happening with Atlantic salmon. These are a specific strain called the Gaspé strain. And we are looking at spawning Atlantic salmon out of season. So this project, we were spawning these fish out of season. So we're expecting them to spawn right now in the middle of summer instead of in the fall, using just photoperiod, so the amount of light that they're getting. So every month we are taking these fish out and we are doing a sample of them. And basically we're looking at hormones. So what hormones are these fish producing at the time of spawn? We can look at that through blood, but the project is, instead of looking at this through blood, we want to see if we can see the same hormone response with mucus. So fish create mucus on their skin, and that mucus has hormones in it. So if we could simply take a mucus swab of these fish and figure out hormone response, that would be a lot less invasive than taking blood. So that is part of the research, is taking these mucus samples. We are preserving those samples, sending them to be analyzed to see what those different hormone profiles look like. So this system is called a Heath tray incubation system. So this is how we would incubate our cold water fish species. So much different than a bell jar system. This is basically trays of eggs that water upwells into each tray, giving them oxygen and fresh water. So the white eggs are the dead eggs that probably never got fertilized. But regardless, if these were fertilized, they would stay in here until they hatched. At that point, they would absorb their yolk sac and we would prepare them for feed. So they'd spend about another month after hatch in this Heath tray, When they're ready to eat, we would take this whole tray out and we would put them in a tank setting. It's called ponding them. We would put them in a tank and get them exposed to feed. And I'll show you our youngest Atlantic salmon. So these are Atlantic salmon that were hatched out in January this year. I'd say they're about 7 months old. This is sort of the smallest diet that we have, called a mash or a crumble. And this is what we start them feeding on. So these fish are hand fed multiple times throughout the day, probably 3 or 4 times a day. Just like small, humans or babies, they have to be fed pretty consistently throughout the day. So Arctic char are in the same family and actually a cousin of the brook trout. So if anyone's familiar with brook trout, they're close relatives. And the reason that we originally had Arctic char was looking at them for food fish potential. So they are very quick growers. They can handle very high densities. You can see they feed really well. One of the challenges right now is there is not a year-round supply of eggs, so it's difficult for farmers to raise them. So we've donated a number of different cohorts to different farms across Wisconsin, and then the rest of these char have been donated to local schools. So many of our local high schools have the opportunity to raise Arctic char in their systems and raise them for food fish. These are actually the young or the progeny of our larger Arctic char. So you can see they have what we call par marks on them right now, which is those little stripes or those spots. So after these fish go through that process called smoltification, they'll lose those par marks and really start growing very quickly. And actually these fish are younger than the Atlantic salmon, so it gives you an idea of how much quicker these grow than the salmon. We want to focus on northern climate species because we want to be focused on research that's going to impact Wisconsin. So whether that be species that are impacting Wisconsin lakes or streams or rivers or the conservation aspect of that, but also what's going to apply to our markets. So what do our consumers want and want to see in the markets here? So walleye, for example, is a very important species to the culture in Wisconsin and the Wisconsin Friday night fish fries. And it's also a really important sport fish industry here in Wisconsin. So we're focusing on that because we want to make sure that we are targeting species that are going to impact our consumers, impact our fishermen positively. So we're less concerned about species that are in the southern parts of the region or the United States, but more that are impactful for our region.